Welcome and thank you for joining us for another episode in the Jane Irrigation Training Series. I'm Richard Restuccia, Vice President of Water Management Solutions. And today we're going to be talking about soil moisture sensors. And precision irrigation improves yields, reduces labor, it conserves water, it does a lot. And what it takes, though, is a lot of different tools to actually make this happen. And there are a lot of tools out there today. One that's been around for a long time has been the soil moisture sensor. But what I've found is that people don't have a complete understanding of how they work, why they work, what the best one is. And talking to Connor a few weeks ago, we said, maybe an explanation of this would be really beneficial to growers out there, to landscapers, so they could really understand what they needed for their application. So that's what we're going to try to convey today to all of you. So thank you for joining us. Connor Cunningham, who you've probably seen before, does a great job on this training. He's a graduate of Fresno State. I think you have your Fresno State Bulldogs shirt on today. There we go. All right. So Connor does a great job for us. He's been working in ag tech now for a little over 5 years. And the thing I really appreciate about Connor is, he really cares about his customers. He wants to make sure that they're taken care of, that they're getting the knowledge, the information they need to really be successful. He really buys into making them successful. And I think he understands that if they're successful, he and Jane will be successful too. And not everybody gets that concept. So I really appreciate that about Connor. So Connor, welcome. Thanks for joining us today.
Yeah, thank you. Thank you for letting me join on again. And I think you said it right. We're kind of developing a series. We've talked about this a little bit. With interpreting soil moisture probe data. And then we talked last time about, designing an ag tech system. And now we're going to be talking, starting to get more and more focused here. What's the right soil moisture sensor for your application? So you guys have done a great job on our team putting together this whole catalog of the irrigation training series. So for anybody who may have missed out on some of these topics, you can always go back and check it out on our website under the Jane Irrigation Training Series. Or if you're like me and you're in the truck all the time and like to listen to podcasts, you can also go wherever you get your podcasts and check out the audio there too. So, thank you, Richard, for your efforts in putting this together. And I'm excited to continue to add on to it today.
Yeah, well, thanks for that unrehearsed plug too. I appreciate that. I didn't know that was coming. I'm really happy. So, and we'll just remind them to subscribe to the YouTube channel too, and they'll get notices that we're on. So thank you, really.
Yeah.
So Connor, I'm really curious to know. You've got a lot of experience. You're managing water now for some growers. You've been involved in this for a long time. You're seeing a lot of different locations. Based on your experience, how many growers do you see out there that are using soil moisture sensors?
Yeah, good question. And I'd have to say it's a majority. If we were to break down all of our users that are using the Jane Logic system, I would say probably 80% plus of our users are using at minimum a single soil moisture probe. A lot of them have multiple probes deployed across their field, in their different soil types, in their different irrigation blocks where they're managing different varieties or different crops even. So it's exciting to see. And I know that there's still more room to grow because, like you said, only 60% of growers still don't even use a type of tool like this in their day-to-day lives.
Yeah. So, well, that's really an encouraging number, right? I was surprised. I didn't think it was going to be that high. So I'm happy to hear that. And of those 80%, do you find that most of them know how to read and use and are actively getting good information out of them for their irrigation programming?
Yeah, again, I would say a majority understand how to use it, but that's why we have our account manager strategy available to our growers. It enables us to continue to have that dialogue with our growers and even offer up refresher trainings, because we understand that it's a lot of information that you have access to. And so we're always here to go back and refresh your memory on some of the information that we may have touched on in the past. And again, Jane Logic really, its heart and its soul is to try to make the data tangible and easy to work with on the end user.
Yeah, so the one of the thing that I wondered about when I started to really look at soil moisture sensors, there's a lot of different ones out there.
Right.
So what are so in not specific manufacturers, but what are the types of soil moisture sensors that you can choose from? I mean, there's a bunch of them.
There are, and we really don't have time to go through all of them today, but I think for the sake of time and for the sake of efficiency, we can really break it down into basically two groups, right? We have our tensiometers, and then we have our electronic based soil moisture probes, or what people commonly refer to as volumetric probes. Those are the two main groups that we see most common in the field with growers, Jane Logic users or not. That's typically what we're seeing as we're working with growers here in the valley and across the western United States.
Yeah, so help us out here, Connor. How does a tensiometer work? I mean, I hear that
Mhm.
term. I know people use it
Right.
a lot, but what's it actually doing? How does that work?
Yeah. So tensiometers have been around for a while, and it's a good method. It's a good method for determining, how much moisture you have in your soil. But a lot of people really like tensiometers because it also tells you how much pull the soil is putting on the water. So the way that tensiometers work, and we'll see an example here in a second, there's a little ceramic tip at the end of the tensiometer, and it's porous, and it functions on the basic physics of a concentration gradient. And so you fill these probes up with water, and the water moves freely between the soil solution and the inside of the probe, that atmosphere in there. So you create this atmosphere and you create a pressure inside the probe. As the soil dries out and as the plant pulls the water out, it pulls and creates more pressure inside that probe body. And so that pressure reading can then be equated to either dry down, field capacity, permanent wilting point, or even pull of the plant pulling the water through that probe body.
So I think these are measured in centibars. Is that right?
Right. That is correct. Yes. Mhm.
So when your soil's fully saturated, what would that reading be? When would you know when to water? How does that work with the tensiometer?
Yeah, that's a good question too. So centibars is actually it's a numerical measurement of how hard the soil is pulling on that water. And based on your soil type, the UC extension has put together a really nice comprehensive guide letting you know what those different values should be based on your soil type. So if this is something you're interested in, you can easily Google, what do centibars mean? And you can find this, and it's free to download from a government agency, which is the UC extension.
Yeah, so I did buy a tensiometer last summer for my tomatoes. I wanted to just try it out and have that experience.
Mhm.
So they work pretty well, right, for the
Yeah,
backyard gardener in particular. Something like that. I just want to remind everybody there's some dye that you have to buy too when you buy your tensiometer, because that water, you want some color to it, right? You have to be able to see that, and to make sure everything's flowing correctly. So one thing about my tensiometer, right, it's about 16 inches long. And so I
right.
know what the value of the water in the soil is there, but really, how would I know the amount of water in the soil at 4 inches or 24 inches or on with that?
Yeah, so that's kind of one of the limitations to the tensiometers is that it's a single point that's sensing. So if you were to want to know what's going on at different depths in your soil, you're going to have to deploy more tensiometers. So you'd have one at your 16, one at your 24 or 28, and then one down at like 36 inches. If you wanted to get a better representation of what's going on in your soil, but they don't all work together. So you'd have to go to each site and look at each site and see what the reading is off of each one of those, which typically we see them deployed where they're very close together so you can see them all in one spot instead of walking around looking.
Right. And that's the other thing about the tensiometer. The ones I use or the ones I've seen all have a dial on it. You just read the dial. You don't need another device to connect to it. So in
Hmm.
certain applications, it works well. But even, in my garden situation, I needed multiple depths and I needed them spread around a
Right.
pretty big area. So I had to buy
Mhm.
more than one.
Yeah. They do have some electrical like data logger conversions or models available, but I don't see those very frequently here in the Valley. They're not as common.
Yeah. So then the other one that I read about a lot is these gypsum blocks.
Right,
Right.
right,
And, I think a gypsum block, that's what I build my wall out of. What's this doing with soil moisture? What's happening there?
right.
How does this work? What is that?
Yeah. And then also on the, in the industry, as we're thinking about chemigation and soil remediation and application, right? We think of gypsum, we apply gypsum to our soil to help break it up and then also to, free up some nutrients. And that's what it is. It really is some gypsum that's inside of a steel mesh, and it uses solid state electronics, and it's functioning off of the basic physics of electrical resistance between the soil probe and the actual water in the soil. And then
So,
just, oh, go ahead.
yeah. So you bury these, or what do you do with this?
Yeah. So just like the tensiometer, you're going to bore out a hole, you're going to auger a hole in the soil, and you're going to put this down inside the hole. You're going to want to wet the hole a little bit, and then you're going to deploy that sensor down in the soil. And then you'll have some wires that are sticking out of the ground. So with these units, you are going to need a logger of some sort. There are multiple different loggers that are available on the market, and the cheapest that I've seen is about $300 for one of those loggers.
Okay. Yeah. Good point. We didn't, so I think a tensiometer runs about $100, right? $129 for a
Mhm.
good one. So gypsum
Right.
block is going to be much less than that, right? But you're going to need the logger to read
Mhm.
what's going on.
Yeah. So it depends on where you're buying them. Again, just doing some Google search and looking around. They're anywhere from like $60 to $100, depending on where you're going to be buying them from. So in a comparison between the tensiometer and the gypsum block, they're pretty comparable as far as cost goes. But there's that additional cost associated with having the gypsum block, because you have to have that data logger to be able to actually do anything with it.
Yeah. So are these accurate? Do you get good data from them?
Yeah, I would say that the tensiometers tend to be a little bit more accurate, but people use gypsum blocks all the time. They're accurate enough to be able to give us an idea of what's going on below the soil surface. But the one downside to using a gypsum block is they actually can degrade with time, because they're made out of gypsum. They're made out of calcium, and as water continues to hit them, they'll degrade with time. So you do need to replace these units every few years or every couple years, to ensure that you're getting good data off of them, because your data will degrade as the calcium inside the soil probe starts to degrade.
Right. And so then does the gypsum block actually measure the pull again of water, or the draw, or simulate, the pull that a plant does that the tensiometer does, or does it do it some other way?
Yeah, it does it the other way. So again, I mentioned the electronics. So, it's when you plug in your little data logger, it sends a small electrical pulse into the soil, and it's functioning off of the basic physics of electricity. It's using electrical resistance to measure how much moisture is in the soil. The more moisture, the more resistance you're going to have as that signal moves through the soil.
Yeah. Okay. Interesting. Listen, we're getting a couple questions that come in, and I just
Sure.
wanted to remind everybody we've got the chat open, as well as the Q&A. If you've got some questions for Connor, just type them in there, and I'll get them to him when appropriate. So, okay. So the gypsum block, viable solution to soil moisture, maybe a little bit more than the tensiometer. And these data loggers, by that name, can I see and record and say, okay, today my soil moisture is this, tomorrow, will it keep a record of that so I can go back and look?
It depends on the data logger that you're using. The $300 unit that I referenced is a handheld data logger, and it has little alligator clips on the end of it. So you'd actually have to go and physically visit the site, clip those little leads onto the wire sticking out of the ground, and then collect your reading. So it's still requiring you to go and visit the actual soil moisture probe site, to be able to get the readings off of it.
Yeah. So, do you have any photos or anything of these?
Yeah, yeah. So I actually created a visual deck or representation of a lot of the probes that I commonly see here in the field. So the tensiometer is on the very left-hand side of the screen here. You can see the little pressure gauge sticking off the side of it. We need that pressure gauge to know that we've refilled it and that we've maintained it properly. And then the gypsum block, what we just been talking about, is the one directly next to that. It's got, you can see it's got its little mesh, and you can see it's filled with the white calcium uh, compound there, and then it's got the little green cable coming off of the top.
Yeah. So, and then the other thing I wondered about those two types is, can we see anything else about the soil? Can we learn about soil temperature, salinity, or fertilizer from these two types of soil moisture sensors?
Yeah, unfortunately, that's another limitation of these devices is, we learned about the limitation of that they're a single point. The second limitation is that the gypsum will degrade, and then the tensiometer requires regular maintenance. It has to have water continually added to it, or else it breaks the adhesion to the soil. And then they just do soil moisture. They don't do temperature or anything else. But thankfully, these aren't the only two options that we have available to us as part of our offering that we can choose from.
Right.
So,
So yeah, you had talked earlier about, tensiometers, and then we talked about volumetric as well, right? So
right.
what do those probes do? How do they work? Tell us a little bit about that.
Yeah, yeah, definitely. So the three probes on the right-hand side here fall into the volumetric probe category. And basically what they're doing is they're measuring a percent volume of water in a soil solution. And again, uses the electronic pulse to be able to read out of it. And the nice thing about these is that they come in various lengths. And I'm going to go ahead and swap to the next slide here because it's a great example to show the differences. And the nice thing about these probes is that they have multiple sensors strewn throughout the length of that probe. So it gives us a better look of what's actually going on in the whole soil profile. So it's important that if you're going to choose one of these types of devices, you're going to want to match it to the root zone or the soil profile that you're trying to manage. So if you have row crops, you don't need a 5-foot probe.
Right.
You can get away with a 2-foot probe easy, and it's also much easier to remove and redeploy each time. And then if you're in grapes, you can get away with potentially a 36-inch probe, or if you want to look down past your target root zone, you can put in a 48-inch probe. So they come in various lengths, so that way you can match it to your situation and your crop specifically, which is incredibly beneficial. So now, instead of having to go site to site, we can actually see all of our root zone and all of our profile in one shot. And then I think you also started to lead into it too. These devices standard are able to read soil moisture and soil temperature. So in case some of us aren't aware, and I'm sure a lot of us are, but the soil temperature is really helpful to have, because if we're thinking about our fertigation and thinking about timing our applications and times of year when to inject, some compounds require a certain temperature in order for the chemistry to be effective when we're injecting it into the system. So this is really helpful, so we can make sure to time and plan our injections.
Yeah, great point, Connor. Thanks. So a couple of questions about this slide now, if I could. The photo on the left-hand side, those are the tensiometers.
Correct.
And so what this is depicting is, so that shows one tensiometer going about 6 inches, the other about 12 inches.
Right.
And then the one on the right is the volumetric.
Correct. Mm-hmm.
And that has different sensors every 4 inches. How does that work?
Yeah, so they have different models. So they have models where there's sensors every 4 inches, every 6 inches, and then even every 8 inches. So, most commonly we're working with probes that have sensors every 4 to 6 inches. So like in this example right here, we're getting, just in comparison between these two tensiometers that are only getting 2 points in the first foot, we're doubling that with a volumetric probe.
Yeah. So then if if I've got some type of tree crop or permanent crop, right, this is really going to help me, because now can I actually see the water go through the soil?
Yeah, exactly. And in my opinion, I think these are the better choice if you're looking at using these extensively across your entire farm and using them as part of your water management, because it allows you to see, what the capacity is of your soil, what the soil is at any point in time, or soil moisture is at any point in time at any depth. And it also allows you to watch the rate more fine-tuned. You can actually see how quickly that water is traveling through the soil better than you would with the tensiometer. If you only just deployed 2 tensiometers, you would only see, they recommend the top and the bottom. Well, how quickly does it get there? It's much easier and much more efficient to use one of these probes that has the higher density of sensors inside of it.
Yeah.
And then also, from an investment standpoint too, these devices are typically made and sealed in resin, and then they're encapsulated inside of a plastic body. So the tensiometers are a plastic and they have a ceramic tip. They're not as robust as these other sensors are. So if you're thinking about longevity and not wanting to spend a lot of money over time, this kind of money can be extrapolated over multiple years, and you're really going to get a lot of money out of your investment in buying one of these types of probes.
Yeah. So, Connor, help me out here.
Mhm.
We mentioned that the tensiometer is 100. The gypsum blocks, you're going to need 300 for a reader. Are we talking thousands of dollars for a volumetric?
No. These devices are more expensive in comparison to the tensiometers and the gypsum blocks, but they're not going to break the bank. They're somewhere around $1,000 to $1,800, and some of these within that price range can even detect EC. So if you have high bicarbonates in your soil, so talking to our west side growers and any of our growers who are using recycled tertiary treated water, you can actually track your bicarbonate levels and your salts accumulating in your soil. So if you're trying to time and be efficient with your acid injection, or maybe even cut back on a few of them throughout the season, this will be a tool that will be available to you to help track that kind of information that you haven't been able to at scale before.
Wow.
Mhm.
That would be super useful, right? I mean, I
Yeah.
usually see the effects of salt in my soil after it's too late. So
Mhm.
this would be really helpful to me, that's for sure.
Yeah.
Um, Jane Logic well, what is that?
Right. So Jane Logic is our software platform that we've developed in-house. And what it does is it helps the display. So instead of having that handheld data logger that you go out and clip some alligator clips to, instead we can actually connect these devices to our C3. I actually have one right here if you have a second.
Yeah.
But this is a C3 that I'll actually be deploying in my own yard here. And you would actually just plug in the probe into this bottom right-hand corner right here. And because I'm going to be deploying one of these in my yard, I also have an EnviroPro probe here as well. And very simply, we strip the wires and plug it into this little terminal here. And then we plug the terminal into the C3, and we're now reading soil moisture data.
Wow. And so that C3 then is sending information up to the cloud
Correct.
using a cellular connection.
Mhm.
And then you are seeing the soil moisture on your computer.
Correct.
Yeah,
And
that's pretty
thankfully,
incredible. Can you see it on your phone or
yeah,
your iPad or whatever?
actually, yeah, it's because it's a web-based app. You can see it phone, tablet, laptop, desktop, wherever you have better internet access, you're able to access your data. So now I can check it pretty much whenever I want, and it's being uploaded every 15 minutes. It's updating what the latest readings are, and it's recording it over time. So thinking about setting goals, like we talked a little bit in my last webinar, setting goals for ourselves, this tool, just a soil moisture probe, can really help us with some of our management goals where we're trying to ensure that we're keeping water right where it counts. And then also making sure that we're not flushing water out the bottom if we don't need to. Maybe we can cut back a few hours on our irrigations during the week, and that adds up to multiple days worth of irrigations at the end of the year. So just having some level of tool out in the field helps us with our efficiency and our practices.
Yeah, and so if I'm a grower in the Central Valley, I can take my family to Pismo or Morro Bay for the weekend and
Uh-huh.
still feel okay about what's happening in my field, right? I don't have to sweat it because I can actually see.
Yeah, yeah. Actually, 100%. I've got a couple of growers right now. One's headed to Maui, and the other one's out in Arizona for spring training. And
Yeah.
they both are Jane Logic users, so they're able to monitor what's going on in their fields while they're away having fun.
Yeah, it's nice to have that freedom, right? Because this is what has locked so many people
Yeah.
into place, is that needing to be there because that's the only way to see. So I think there's a lot of freedom there. We got a question coming in about, does the C3 stay connected in the field? So is this something you wire up and keep connected, or do you have to go back and rewire every time?
No, no, yeah. So this unit right here is cell based, and so it stays connected to the cloud. And like we talked about in our last webinar, we also have radio options too, where cellular reception might be a little bit more tricky. So we would actually deploy this unit. I'll go ahead and go back to the title slide here because it's a drawing of what the actual C3 looks like. So you can see that the C3 is put inside of a housing that keeps it safe from the elements, and then it's wired to a device, and then it stays there out in the field. We do have row crop growers who use these where they're pulling them in and out of the field, but it stays connected to the cloud the whole time. So just as long as it has some sunlight to keep that battery charged, you're going to be in business.
Yeah. So is this the typical installation that we're looking at right here?
Yeah, yeah. So we've actually learned from the growers and found out that talking about the majority of our growers using soil moisture probes, we've actually created a bundle based on the feedback of the growers. So you're getting a C3, the enclosure for the C3, the solar panel, a pressure sensor that we can tie into the irrigation line, and then you're getting a soil moisture probe, the length of your choosing. So depending on your crop, we can select a length to match the root zone that we're trying to monitor.
Yeah, that's fantastic, right? It's so easy to customize to what I'm doing, and I don't have to do a lot to change that. So I really like that. So one thing that I would think, though, that is where I put my probe is really going to matter.
It does.
And if I drop it underneath a emitter, it's going to be wet a lot more than the actual roots are. So what do we do about this? Where do we put these probes?
Yeah, yeah. No, and that's a very serious consideration. So there's a few key points that we need to consider when we're thinking about deploying these soil moisture probes, because I've had growers reach out to me saying, "Hey, I don't think my probe is working. It's way too dry. I've been turning on water and I'm not seeing anything." And it's because the emitter's too far away. So there's a danger of putting it too close and then putting it too far away. If you put it too far away, you're only going to be seeing moisture at the lower levels. If you put it too close, you risk that water channeling and creating air gaps around the probe. So thinking about drip emitters, we want to put it close enough that we're seeing the whole irrigation bloom in the soil, but we don't want to be so close that we have channeling. We don't want to be so far away that we're not seeing any moisture at the upper depths.
Mm.
And then we also want to, again, we've mentioned it a couple of times here, but I'll mention it again. We really want to make sure that we're selecting a probe that is representative of our root zone. And I actually like to suggest to the growers that I work with going a little bit deeper too. So that way we not only see, hey, are we putting water in our root zone that we're managing, but are we actually going beyond that? Can we bring that back a little bit? And again, save a few hours on some irrigation during the week, or even during each irrigation, and save multiple days. That saves on water, that saves on your pumping costs, that saves on your labor. That adds up at the end of the season, year after year. And then also based on your emitter type too. You can't place a probe the same way in a drip emitter system as you would in a microjet or a micro sprinkler system. So I actually created a diagram because we really, this is a huge risk working with the jets, because they're so finicky that they can be knocked one way or another, and then the probe's not going to be reading it right. So we always suggest, and we call it the donut, right? So I have this blue donut that I've drawn down here, and I've represented the sprinkler with an X, a red X. And we have to remember that, as tempting as it might be to deploy that probe right next to the sprinkler, 80% of that water is actually in the outer edge or the outer ring of that pattern. So you have to know what your throw is of your micro sprinkler or your jet that you might be working with. So If you don't know what that is, turn on your system for a few minutes, see where it is and stake it out. We also suggest staking that jet down if possible. So that way, as the lines are contracting and expanding due to heat and cold during the season, and people are moving in and out, machines are coming in and out of the field, that you try to mitigate the risk of that sprinkler moving and then throwing off your data set.
Wow, great suggestions. Yeah, thank you. So we have a question coming in, and it has to do with soil moisture or soil probe installation, right? If I'm using an auger, I'm
Right.
going down, 48 inches or even a little bit more,
Mhm.
and I put my probe in the soil, do I pack the soil back down next to the probe? How do I do this? How do I
Mhm.
make sure that the soil next to the probe is representative of the soil that's in the field?
That's a great question. And it depends on the probe, as much as I hate answering like that. But I'm going to come back up to these probes here. The nice part about some of these probes is that they have a slight taper to them. And there's an auger that has that same taper, which is the Syntek probe, this white probe on the very right-hand side of the screen. So with that one, you don't have to create any slurry. You don't have to do any packing. You drill the hole out and then you slide it in there and then you wire it into whatever device. In our case, we would wire it into the C3. But these other two volumetric probes here, the AquaCheck, the silver one, and the EnviroPro, the green one, require what's called slurry. And so what you're doing is you're creating a soil solution with water. So you capture all that dirt that you pull out of the hole that you augered, and you mix it with water to get a special consistency of the slurry. And then you put your probe in the hole, put your slurry in the hole, and then let it dry for a few days. The longer the probe, the longer the dry time is going to be. Just as a heads up.
So then that's what's going to take you to zero in a sense, and then you're going to make your readings after that.
Well, it's going to take you over 100.
Yeah, right.
Because you're going to be past field capacity for your soil. So, if anybody needs any guidance or needs any tips and tricks, we're available. We'd be happy to help you walk through it. It can be a little bit of a tricky process creating the slurry, but I can do it. So that should say something.
So God, you're underestimating yourself. Let me tell you. So we got another question coming in, and it has to do with using EC readings, right? Soil salinity readings. Can we also manage our fertilizer?
Yeah. So that's kind of the golden egg. The next step in soil probe evolution is being able to specifically look at very specific nutrients that are applied to the soil. A couple of companies have tried, but it hasn't been successful in the past. So currently we're still at the EC level reading. I know that there's literature out there that talks about various EC readings and how that equates to different applications. So that's something that's going to take a little bit more research, but is doable. But we can't detect specific fertilizers with the equipment that we have available today.
Yeah. So somebody was saying though that quite possibly you can see the nitrogen moving through the soil using a salinity reading. Is that right?
Again, you're going to have to look at some of the reference material, but I know that there's most likely material out there that will tell you, hey, an EC reading of X can equate to nitrogen versus, if you're looking at sodium or bicarbonates in the soil.
Yeah. Okay. All right, great. So these volumetric soil moisture sensors are the one that you particularly like, can tell you EC, which you can use to not just watch salinity in your soil, but manage your fertilizer as well as soil temperature.
Yeah. Well, really the biggest thing for me is being able to look at multiple points within our root zone, because we're not just managing one depth. With these other probes, they might be a little bit more cost effective up front, but there's other costs that are associated with it. You have to maintain the tensiometers. They're a little bit more brittle with the watermarks. They dissolve with time and they're not as accurate. And so even though you might be saving a little money there, you really don't get the value of the data that you have with one of these volumetric probes here, where you're having the multiple depths being monitored. So you can actually track, what's the capacity. You can track, how fast water is moving through the soil. And you can even spot issues easier too. I was working with a grower. We were trying to test whether or not a surfactant that he was applying to his field was effective or not. And having access to all these depths within his root zone really helped us to see that it really wasn't. He was being sold the surfactant and it wasn't giving him the results that he was expecting to see. And then as soon as he applied some fresh water, boom, all those nutrients opened up and we could see the whole profile flush out. So, you can tell that I have a lean towards these probes because I really do honestly believe that these are the better solution. And then again, the soil temperature, it helps us plan our injection and plan our applications throughout the season and helps us achieve some of that spoon feeding that a lot of people really attempt to go for, and what organizations like the ITRC recommend, for better yields and better management practices.
Yeah, that's a great point. There's a lot of experts recommending this right now. So, Connor, for the 20% of growers out there that are not using any type of soil moisture sensor, do you have any advice for them?
Just go for it. Give it a shot. See what could happen. I mean, if you already have the C3 out there, you can see all the ports on this thing, right? If you're doing just the control side, you still have the room for the soil moisture probe. If you have the ability, I would say give it a shot. You could really learn a lot, and it's more data. It's more information that you can pull from and you can work from. And as we're going to see, and as we already are seeing, with increased regulatory restrictions and increased eyes looking at how we're being good stewards of the land, data is king. So having as much data behind us as possible is also a great security measure and a great insurance measure too.
Right. So Connor, for everybody who's watching and thinks of a question they had for you 2 hours from now or 2 weeks from now, is there a way they can get a hold of you?
Yeah, definitely. So I'm going to put my information up on the screen right here. So if you're thinking about utilizing some of this technology or utilizing some of these tools on your farm, reach out to me. I'd be happy to brainstorm with you and think through, some of your thoughts and help you to devise a specific design to fit your situation specifically. And then we also have an offer today. So anybody that wants to buy some of these probes and start working with the JNLogic platform, we're going to offer 15% off any probes. As long as you mention that you were a part of this webinar, we're going to give that as a gift to our audience today.
Well, Connor, that's a really generous offer. Thank you for the offer. Thank you for your time today and taking us through soil moisture sensors. I certainly know I did a lot of research ahead of time, but I learned so much during this time. So thank you. It was really helpful. Thanks to all of you who attended today. We really appreciate your time. Please remember, as Connor said earlier, you can see any of our almost 100 trainings now at janesusa.com/trainings, or just search trainings in the search box and you'll find them all there. We're also on Spotify, Google, and Apple Podcasts if you just want to listen to us while you're driving around in the truck. So anyway, thank you again, Connor. Thanks to all of you. We really appreciate it. And don't forget to subscribe to us on our YouTube channel as well. All right. Thanks, everybody.
Thank you, everyone.